So, hello everyone, and good evening to this episode one of this online series that we are going to start from today. So, it is good to have all of you join online on a Friday evening. This is the first time that we are conducting such an online stream. So, we are expecting a good experience for ourselves also, and we are expecting that you also enjoy this session and the series that we are going to conduct every month. So I hope my voice, etc., all the technical details are fine. My voice is properly audible to all of you. So all of you are either joining on YouTube live or you are joining from the LinkedIn page. So you can add your comments in the live chat, and we are able to see those comments over here. So welcome once again. And what we will do is I'll just run through a small introduction where we would uh, where we would like to inform you what is the thought we are having in our mind in conducting this online series. So let me begin by this presentation, and I'll tell you how the idea came to our mind. So, as most of you, I think you are aware that we have been conducting uh, at AuxEn, me and my wife Akanksha, we have been involved in conducting the training and skill development of civil structural engineers. It has been almost 7 years now. In addition to this, we also run our structural consultancy firm, and for the last 2 years we have been operating completely online. So we have been conducting courses and programs for engineers through the online medium. So we get a chance to interact with a lot of structural engineers every day, and I must say that all the engineers that we interact with, they are actually doing a lot of good work with lot of passion and lot of enthusiasm and commitment. But what we feel is that sometimes uh, there is a lack of mentorship and a lack of guidance that they do not get sufficient guidance, and there is a lack of mentorship that they face. So these are some challenges or problems that we think the young structural engineers face. So therefore this idea came to our mind, that through this online series, we will try to create a platform where the structural engineers can come together, they can interact, and they can share their uh, problems, they can share their ideas, and they can share their experiences. So, we will be trying to conduct two such episodes every month. So, we'll try to have it fortnightly, and we will live stream these episodes on YouTube and on the LinkedIn page. So that is what the idea is. Right now, this is a nascent idea, so uh, it is at the preliminary level. We will let it evolve with time. So with time, we are sure things will become better. We will evolve it even more in a better way. So how our each episode will happen? So we have thought that we will be conducting these episodes in different segments. In each episode, we will start with some common problems that we as structural engineers face, and we will discuss the possible solutions to them. So these problems may be related to they may be related to analysis, they may be related to design, they may be related to different codal provisions, software application or implementation, construction practices, execution, or any other problem that falls under the scope of structural engineering. So this will form our first segment where we take the problems. In the second segment, we will discuss ideas. We had circulated a Google form a few days back wherein we had asked you to put some ideas, put your thoughts. So we will discuss some ideas on how to make the work done by structural engineers more efficient and how to improve the overall productivity. In the third segment, every episode we will try to feature a young structural engineer, and we would like to learn from their experiences, uh, experiences that they have gained during doing some projects or doing any other work. So we would be sort of having a conversation with a structural engineer every episode. That will be a fun part, I believe. And then we will have an open discussion with the live audience that will attend the program. So this is what we are thinking, and this is how we have thought that our episodes would be conducted. So this was about the first segment. Now I move on to the next segment, and that would be the segment where we discuss the problems faced by structural engineers and their possible solutions. So for this time we have taken two commonly faced problems. I would not say problems, but things that we are often asked. Many of engineers ask us this issue quite often. So we have decided to take two such problems in today's episode. So let me just quickly go through it. So the first problem that we will be taking would be the doubt about the concealed beam or hidden beam. So, how many of you faced this issue? Concealed beam, hidden beam, whether to provide concealed beam, not to provide concealed beam? Is concealed beam good enough? How many of you face this issue? I think most of us face, isn't it? This is a great difficulty that we come across where the architects would tell us to provide a concealed beam because they do not have the sufficient depth available, or uh, they don't want anything to be uh, hanging below the slab level. So every project, wherever is saying every project he faces this uh, difficulty. Every project he faces this difficulty that concealed beam is a major pain point when it comes to structural engineers. So it is a major point of tussle between the engineers and the architects. So let us try to address this issue. What is concealed beam, and whether or not it is good enough? Is it a gimmick? What it is? So that is the first thing we will like to briefly discuss, and I would invite your comments if you have to type in the chat box. The second problem that I will be taking today would be the issue of column design in ETABS. And when it comes to these three options that you see in the ETABS, one is the ductile option. In the overrides, ETABS overrides, you see this option, RCC design I'm talking about. So ductile, ordinary, and non-sway. So typically you see these three options, and quite often there are uh, confusion in our mind, which option to take, when to take. So that thing we will try to address. So these are the two problems we are going to take in our today's segment. So first problem, concealed beam. It's a common practice I just now discussed in RCC projects to provide concealed beams, hidden beams. Typically, people or architects or structural engineers would provide concealed beams for two reasons. One reason is to break the span of slab. So if your slab is very large and if you want to break the span uh, in order to reduce the thickness of your slab, you often try to provide a concealed beam, or your architect will tell you concealed beam de do, sab theek ho jayega. So concealed beam is when you try to provide it to break the slab span. Quite often we provide concealed beams to uh, control the deflection of your slab, and we also provide concealed beams when we want to support some brick walls. Okay, so these three reasons are quite common, because of which we are we may provide, or this idea may come to our mind to provide a concealed beam. So I've drawn a quick hand sketch. I have not taken images from the internet because of the uh, copyright issues. So I have tried to draw a hand sketch over here, and you can see a big slab span, and we have put a concealed beam indicated by CB, and then in the section AA on your right side, you will see that the concealed beam is having the same depth as that of your slab. So is it good enough? Are they really effective? That is the big question that we face. So anyone would like to comment on this? So the dynamic company, his name on YouTube, can we use the Canadian code formula when designing by the IS code? Good. So any comments on this concealed beam? Are these concealed beams effective to your mind? Are these concealed beams effective in breaking the slab span? Are they effective in controlling the deflection? Anyone would like to comment over here? Okay, so in the meanwhile, people are commenting. Yeah, if you want to comment, you have to write it in the YouTube comment section, live chat section. You will have to write it, or if you are joining us on the LinkedIn page, you have to write it in the chat section. Okay. So what we need to understand is that quite often the concealed beam do not have sufficient stiffness. Okay, they do not have sufficient stiffness, and because of the small dimensions, they cannot be. They are generally flexible in nature. So if they are not sufficiently stiff, then you cannot expect them to provide adequate stiffness to slab. Okay, if they are not sufficiently stiff, you cannot consider them to be effective in either in dividing the slab span or in controlling the deflection. But then the question comes to our mind, that when can we consider a concealed beam stiff enough? Okay, when can we consider a beam stiff enough? That is the question that may come to our mind. So when we come to, or when we look at the IS 456 code, the problem with IS 456 is that if you look at the table number 26 given in IS 456, I think many of you are aware that IS 456 table number 26 is for wall-like supports. So the coefficient table that you have, it is only for wall-like supports. That means very very stiff supports. So actually speaking, the IS 456 does not consider the beam stiffness at all. Okay, if you look at the American code, American codes do consider the beam stiffness in their analysis and in their design coefficients. So actually, American code does not have this technique of finding out the slab moments by coefficient method. They just go for an equivalent stiffness method. Okay, so yeah, I'm just writing. I'm You can see the comments that we are getting. So these comments are not my comments. These are the comments of our audience, those who are joining us live. So not necessarily we agree or disagree with these comments. I'm just trying to put these comments on the screen. All right. So yeah, so these are not my endorsements. These comments are being received on the live chat, and we are just displaying it over here. Anyway, coming back, so the Indian code, we do not take into account the stiffness of supporting beams. If you look at the table number 26, uh, it is only for wall-like supports. So we are in a fix whether or not the beam that we are providing is wall-like. Is it stiff enough? We don't know actually. Okay, further we don't have much idea that whatever concealed beam we are providing, will it be able to control the deflection? So for a beam to control deflection and for beam to break the uh, span of the slab, it needs to be stiff. But how to judge that? Indian code does not help you, so then we take help from the Canadian code. As someone of you had just mentioned, I'll just go back in the chat. So, Dynamic Company, I don't know his name, his YouTube name, he goes by the name Dynamic Company. So, he said this thing, can we use the Canadian code formula? So, that is what I'm coming to right now. So, Canadian code gives you a recommendation where the depth of concealed beam, if it has to be sufficiently stiff, it has to be greater than or equal to 1.26 times the depth of slab multiplied by L over B, where L is the length of your beam and B is the width of your concealed beam. So L over B whole to the power 1 upon 3. All these clauses and this understanding, I got it for the first time from the book of uh, Pillai and Menon. So Professor Pillai and Professor Devdas Menon, a very effective book written by them on RCC design. So for the first time about this issue, I read it from their book. So thanks to them for creating such a wonderful book. I would strongly recommend those who are those who want to uh, those who want to read as an advanced text RCC designs, they should refer to this book by Devidas and Menon, a truly a masterpiece. Anyway, so this is their formula. I mean, they had taken it from the Canadian code. So Canadian code gives us this recommendation where the concealed beam depth has to be greater than or equal to 1.26 times the depth of slab multiplied by length of beam divided by the width of concealed beam whole to the power 1 by 3. We cannot write it over here using our pen and that notepad, digital pen. I'm not able to write it right now. So what I have done is we have included a small calculation. So assume that your length of the concealed beam is 5 meters. So if I go back, sorry, assume that the length of your concealed beam is 5 meters and the width of concealed beam is 400 mm and the depth of slab is 150. So then the depth of concealed beam that would be required would be 440 mm. Imagine. So if you are providing a concealed beam width of 400 mm, then for a 5-meter beam, you would require a 440 mm depth. That is, I mean, we don't provide that sorts of depths. We will provide, let's say, the concealed beam depth equal to 150. So if this is not being followed, then your beam is not sufficiently stiff. If your beam is not sufficiently stiff, you cannot expect it to provide uh, effective deflection. I mean, you cannot expect it to provide effective resistance to the slab deflection. Neither you can expect that beam to provide uh, to help you to break the slab span. Okay, so if your beam is not following these dimensions, you cannot say that your beam is concealed. So in most of our cases, what we are providing, our beams are not actually working quite well, or they are not working in the manner we want them to work. So this is what I had to present about this issue. What you can instead do is you can add steel beams. Okay, so this concealed beam is a gimmick. Don't fall for this gimmick in just providing 4 bars inside your slab, 4 bars of 12 mm and tying it with some stirrup arrangement. It does not help you. Instead of that, what I would suggest is to provide some encased uh, steel beams. Okay, steel beams are much more stiff and they will actually help you to control the deflections. So try to go for a steel beam network. So if you want to provide something concealed, go for an ISMB. Let's say if you have a ISMB one, sorry, if you have a slab depth of 150 mm, go for ISMB 100. That way you can manage the cover also and you can effectively fit in your steel beam inside your slab. Actually, we have done some projects where we have encased steel beams inside our slab to control deflections and to manage a few other things. So this is one thing I wanted to tell you. This is a problem that we quite often face, and uh, this is a possible way out. So normal RCC concealed beams do not work. It is better to provide concealed steel beams if at all you want to provide it. Mr. Rahul is adding over here that there is a new addition. A new addition to the clause or new addition to the book. Okay, I'm not sure. All right. So this is what I had to present for this concealed beam issue. The dynamic company is asking, are there any references for calculations related to providing encased steel beams? See, for NK steel beams, one reference is that because these beams will be totally encased inside the concrete, you can take them as laterally supported. Okay, so if you have if you have gone through steel designs, there are two types of beams: laterally supported and unsupported. So because our steel beam would be completely inside the concrete, you can effectively take them as laterally supported beams, and you can find out the moment capacities accordingly. Other than that, any reference, I would say that you can refer to some European codes or British standards which deal with the composite beams. So Indian standard, you don't have the composite beams covered in any of the Indian standard. So you can refer to EC 1994, and I think the part number is, I am not remembering the part number, Eurocode 1994. I think part number 4 or 5, I think. So that covers the composite beam design. So you can refer to those things. Mr. Venkatesh is saying over here, can you please show us the site photos, how it is installed at the site? Yeah, right now I don't have the ready photos, but I will try to bring it for the next episode. Yes. Okay. So this was one of the problems that I thought we should discuss. The next problem that we often face in ETABS, those who have been using ETABS for RCC design, this another problem we quite often face, where we often complain that the ETABS column design is very heavy. It requires more reinforcement percentage. बहुत ज़्यादा steel आ जाता है. This type of comments we quite often hear from people. Okay, so it is very important to understand those who are the users of ETABS about this issue. Okay, so ETABS has three options for column design. Not for actually, it comes as an override. So ETABS has three options for column design. They are the option using the ductile, uh, or you can design your columns. When I say columns, it applies to the complete frame, but on the columns it creates the maximum, I would say the maximum effect of these options is on the column. Therefore I am saying column right now. So ETABS has three options for frame design, I should say. Those three options are ductile, ordinary, and non-sway. Okay, these options you can access as overrides in ETABS. So which option to use and what is the purpose and importance of each option, that is one thing we would like to discuss. Why we are discussing this? Because this is quite often the problem faced by engineers, when to take which option. So people, you can write your thoughts about this issue: when to choose ductile, when to choose non-sway, when to choose ordinary, and what happens when we select a particular option. If you have any thoughts, you can just type in. Okay, so ductile column in ETABS, when to select this option. So whenever you are designing your structure, and when IS 13920 is applicable for that structure, then you should design it using this particular option. Okay, so when you choose this ductile option, again I am repeating, this is chosen as an override. So you have to select all your columns in ETABS, and then you go to overrides option, and then you select a particular override. So if your structure, you are going to design it as per the, if IS 13920 provisions are applicable for your structure, let's say you are in zone 3 and above, or your structure is greater than 15 meters in height in zone 2 and above, then 13920 is applicable. And if it is applicable, then you should go with the ductile option. One important thing to understand, that ductile setting is the default setting in ETABS. Okay, so whether or not you choose it, ETABS as a default designs columns by ductile. All right, so it is important to understand that when you choose this option, all the applicable provisions of 13920, including the beam column capacity ratio, which is quite often a pain point for us, for the structural engineers, and the joint shear, all these calculations are checked and considered. So then ETABS, what it does is that it calculates the effective length in accordance with Annexure E of IS 456. Okay. In Annexure E of IS 456, it is an annexure to find out the effective length of column. So for that, you need to find out the stability index. Okay. So when you find out the stability index, I mean all these things are being done by ETABS. So stability index Q, it has a formula given to you in Annexure E. So you find out the stability index, and then if the value is less than 0.04, the column is considered as non-sway, and if Q is greater than 0.04, it is considered as a sway column. All right. If it is a sway column, then ETABS will calculate the effective length in accordance with the figure number 27 of IS 456. If the column is non-sway, then the effective length factor will be calculated in accordance with the figure number 26. Earlier it was 27 for sway, and for non-sway it is figure number 26. And then if your final L effective by B or L effective by D ratios exceed 12, then it leads to additional movements, and those additional movements we calculate as per clause number 39.7.1 of 456. Okay, so that is what happens when we choose the ductile column option. Now I have written this in quotes. So the architecturally suitable columns, the columns that architects love to provide, 200 wide columns and 400 or 500 or 600 other dimension columns. So the architecturally suitable columns often face this difficulty. Okay, so quite often you will see that when you are designing the sizes as per the architect's requirement, very thin columns, you quite often face this issue that your column about the minor axis will become a sway column, and it will attract a very large additional movement. Okay, have you experienced this type of a behavior? Anyone who has experienced this behavior, that their column became a sway column about the minor axis because it had a very small width about that axis, and because of that it had a very large additional moment, and that led to very very high percentages in your columns. So this is quite often an issue which we face. Okay, ductile columns. Yeah, these days, you in the newer versions of ETABS, you have this option to turn off the beam column capacity check uh, in the design. So if you want to not check your column for the beam column capacity ratio as per IS 13920, you have the option to turn it off. Okay, but you should not be doing it if you are designing it as a ductile column. It is not advisable that you don't uh, check for the beam column capacity ratio. Anyway, so this is about ductile columns. See, till now there's no problem if we have applied earthquake loads. If you are designing your structure as per IS 13920, you have to apply earthquake loads, then there is no problem in choosing the ductile option. The problem occurs when you are not designing a structure for earthquake. Okay, so suppose you are in zone 2 or in lower zones, or you are designing a structure where you think that earthquake loads are not required. Let's say you are designing a small residential project. I'm not saying by this that residential projects are not important, but for small residential projects generally we will not apply any earthquake load as such. Okay, so if you are doing those sorts of designs where you have not taken IS 13920, or you have not considered earthquake loads at all, that means you are just designing for dead load, live load, then the actual problem appears. So what did I tell you? The default setting in ETABS would be what? What would be ETABS doing as a default? It would be designing the columns as ductile columns, whether or not you apply anything or not. So as a default setting, it will try to design it as ductile. So even if it tries to design it as ductile, or if let's say you have not defined the earthquake loads and it is trying to design it as an ordinary, even in those two situations, which two situations, ordinary or ductile, if you have not applied earthquake load, then the default setting in ETABS, listen to this carefully. So the default setting in ETABS is that it will not calculate the stability index, and it will consider your column as a sway column. Okay, I'll repeat it. What I'm saying, suppose you have not applied the earthquake loads, okay, and you decide to design your columns, and your columns right now, let's say they are being designed as ductile columns, or even if you choose and change them to ordinary columns, ordinary means which are being designed by 456 alone. So even if you choose ordinary or ductile and you have not applied the earthquake loads, then ETABS considers as a default setting the column as sway columns. So what it does is it will consider the effective length uh, in accordance with the figure number 27 of IS 456, and the minimum K value it will take would be 1.2. Okay, so see, you did not apply earthquake loads, but still ETABS will take it as sway columns. It will take the corresponding effective length for sway columns from figure number 27 and calculate the K value. The minimum K value in any case has to be taken as 1.2, and then it will calculate the effective L effective by B or L effective by D ratios, and accordingly it will design the columns for additional movement. So this is a problematic option for us. If we are not designing our structure for earthquake, then this setting becomes quite problematic. So this option should not be chosen then. Do you get it? Is it clear? If you are not designing a structure for earthquake, please go to the overrides and do not design your columns either as ductile or as ordinary. You will be in a problem. So then what do you do? It is better in that case to design your columns as non-sway, which is the case I'm talking about. I'm talking about small structures where you are in zone 2, or where you have chosen mostly in zone 2, where you do not apply earthquake loads and you have chosen to design it without earthquake loads. So if you choose to do that, always go to the overrides and select your columns as non-sway. So when you do this non-sway, what happens is that for this option, ETABS takes the column as non-sway columns. Then it will calculate the K in accordance with figure number 26 of IS 456, and accordingly the L effective by B or L effective by D ratios will be calculated. So this option, to summarize, should be chosen when not designing for EQ loads. Okay, very important. So this is what I had to tell you about the ductile, ordinary, and non-sway columns. If you are designing for earthquake loads, very simple, go ahead with ductile. ETABS will automatically consider all the provisions, all the clauses of 13920. Very simple. But if you are not designing for earthquake, do not choose ductile or ordinary options. Then go for non-sway. Yes, so the dynamic company is adding, if we are designing columns as non-sway and applying EQ loads, what can we say about its earthquake resistance? See, it is one thing to say about earthquake resistance, but the thing is you are doing it incorrectly. If you are applying EQ loads, let ETABS calculate the stability index, okay, and let it decide whether your columns are sway columns or non-sway columns. What you can do is, if your column, you see that your stability index are coming to be greater than 0.04, then you can try to reproportion it maybe. See, in the end, you design it as non-sways, but at least try to reproportion it. That would be my suggestion. So if you are designing columns where you are applying EQ loads, but designing them as non-sway, that is not a good practice. At least let ETABS calculate the stability index to give you a good idea. Okay, right. So this is what I had to say. So these are the two problems in our first segment that we took uh, in today's episode. Now, yes, any last comments before we move to the next section? Okay, so this was our segment where we took the commonly faced problems by structural engineers. Now we will move to the next segment where we will be listening to experiences, and where we will be listening to the learnings from a fellow structural engineer. So, why experiences are important? Because whatever you do, whatever you learn, in the end, whatever remains are only the experiences, isn't it? As Sri Krishna says, Sarva karma akhilam partha jnane parisamapyate. So, whatever you do, in the end, only the knowledge remains and the experience that you derived from it remains. So whenever you meet someone, don't ask them that what they have done, what are their achievements. Ask them what are their key learnings or what have been their experiences. That actually teaches you a lot. So keeping these things in mind, in this segment we will try to invite structural engineers from different backgrounds who are doing different work, and we will try to learn from them. So, in this episode, we have invited engineer Sandeep Dev. He is from Tripura, and right now he is a structural design engineer working at the Siddha Group, Kolkata, and he is a very well-known face on YouTube, on LinkedIn. He is the founder of Illustrica, a very popular online learning platform for structural engineers, where he conducts some very good online courses. He is a YouTuber and a blogger also. So it's great to have him today for this episode. So let us hear it from him. Presenting to you, Sandeep Dev.
Hello, sir. Thank you so much for having me today.
Yeah, hello Sandeep. So it is always good to talk to you. And if
Same.
you could briefly tell us about your journey till now, that would be great. First question for us. So after your engineering, in short, if you could tell us what you have been doing, and right now, where are you?
Okay. So, to be very honest, after completing my graduation, I really had no idea what I'm gonna do. So the journey started basically like all other engineers do. Like I started learning softwares. So this is a very, you can say, what I feel that we young engineers think that learning softwares will help us uh, in some way to get into the industry. So thinking that, I have also started learning the softwares, and this thing is very, I don't know, from my school days only. Teaching something to, like, after learning something, I really love to teach that to someone else. So I used to share my learnings with my friends, with my juniors, and maybe with some of my seniors also in that period. But in very short note, I found that learning softwares or knowing the tools of a particular software will not help us at all. uh, in that case, I struggled actually, because how to implement the real scenario, or how to implement the code provisions to the software, and after implementing that to the software, how to understand whether the software is giving us the true result or not, whether this is the correct one, how to judge that. So in that case, I struggled a lot. But yeah, thanks to you also, and uh, uh, the people from whom I have learned, like, I'm saying this openly, that I have learned a lot from Arthur sir actually, about the structural design, about the engineering judgment actually, how we should make, and obviously from various others platforms. So the thing I realized that, like, if we have to learn, we cannot focus on one particular, maybe one particular thing. We have to be very dynamic about our learning. sometimes people think that why should I invest my time, or why should I invest my money on these learnings online or offline. But what I would suggest to my juniors or to everyone, that we have to invest our time, either our time or money, to learn. Otherwise, it is very difficult to get into the industry in today's scenario. So this is my small, you can say, experience that I'm sharing. I don't know, maybe it may vary to person to person. So
Yes.
it wasn't very easy for me, but yeah, I got into the flow and I'm doing good. Yeah.
Good, good. So right now you are working as a structural design engineer at the Siddha Group, and
Yes.
as if
Exactly.
I understand correctly, you are involved in the proof checkings of big structures.
Yes. Yes.
And
So,
so, what exactly do you do? If you could briefly tell us, because this is
yeah.
a
Sure.
new thing, because not many of us are doing this thing as a profession,
Yes.
checking, proof checking, and what exactly do you do?
So yeah, proof checking. Yeah, we do our in-house proof checking for the structures that Siddha Group is doing. Actually, Siddha Group is a developer, and what you will see that very few developers will have their own structural design branch. The developers mostly take the drawings or design from the consultant, and they do the you can say third-party vetting, or you can say proof check, and after that directly they go for you can say construction. But fortunately, and I think it is a good practice for like it should adopt by all the developers, that they should have a own structural design team. So in Siddha Group, what we do, whatever structures we are getting from our consultant, whatever structural models, drawings we get, we used to check thoroughly whether the structure is, whether the modeling is compliant, whether the decisions they have made, it is code compliance or not. Because uh, after all, we have to follow the code. Whatever is given in the code, we have to follow that, right? And after that, we have to understand, or we have to maintain the economy also. So being in the client side, our aim is two things. One is, uh, you can say, the design the consultant made, it should be code compliant, and one more thing, it should be economic. So the most the you can say first and foremost thing we do is this thing only: thoroughly checking all the models, the drawings, before releasing it to the site as a GFC. And yes, to keep our you can say economy in mind, sometimes we do comment, like whether maybe uh, if I am also a consultant, I will always try to give some higher sections so that I am in the safer side. But being in the client side, I will be like, it is our responsibility to reduce the cost. It's
Correct.
not like we are compromising with the, you can say, structural you can say integrity, but obviously we have to keep that in mind. So yeah, in my job is to do that only, checking the structural integrity, and you can say checking the how economic the structure is. So this is my daily
So,
job actually. Yeah.
so actually, it is a difficult balance to maintain because on one side you have to ensure that IS codes are being followed, and on the other
Yes.
side you also want to achieve economic solution. So
Yes. Exactly. Exactly. Yeah. If I'm only a proof checker, then it is very easy for me. I will see whether it is code compliance or not. I will comment on that, and I'll that's it.
yeah,
But being
yeah,
in the client side, I have to keep the economy in mind. So yeah, that is a tough job. I'm also feeling that.
right,
But yeah, it's a good learning here. I'm
yeah,
learning a lot in my initial stages actually.
right. If the audience have any questions for Sandeep ji, you can just write in the comments, and we will take a few questions from the audience also. So one thing, because we face this issue quite often, that the designers sometimes they do not share their structural models with us. I mean, there are some projects where we also act as proof checkers. So there we have seen that the structural designers they do not, or they are very reluctant to share their models. So do you face that sort of challenge also, or
No, actually, unfortunately, it is already it's a deed made by our consultant and our company that we have they have to share the models, and we'll be checking
Okay.
from our side. And yeah, we also do have our third party vetting consultant, but as I said, we have to keep the economy in mind. The proof checker will give their whatever they think, but the economy they will not see. So that's why we have our own in-house team, and we are doing it every day actually.
And what are your procedures for checking the drawings? Because finally the drawings are going for the execution. So
Yeah.
how do you ensure, what are the
Now,
processes that the drawings are in accordance with the design or model?
yeah, so this is a very tough job actually. That's what I was going to say. The basically while checking the drawing, while checking the model, it is very easy because most of the people follow the same rule. But
Yeah,
while checking the drawing, we have to think as the designer who have
yeah,
designed the structure. So sometimes the drawings are maybe I as a designer I will make a drawing in a different way. As a designer, the consultant whoever is working there, he will make the drawing in a different way. But when I'm checking his drawing, I have to think about like think it in his way. Yeah,
yeah,
so what we do, we basically follow the models that is shared with us. Suppose I am checking a, drawing of a beam, so I'll be checking the I can say models first. And one more thing is very important, which is coordination between the structural drawings and the
yeah.
architectural drawing, along with the plumbing, electrical drawing, everything. Because
True.
if I'm releasing a, suppose we have a you can say sleeve in the beam for passing the pipes or maybe the electrical wires, and
Yeah,
I have not checked that I have released the at site. Now site have done this. Yeah, there are procedures to make the sleeve after the construction also, means after the concreting also. But it's a extra job that we need to do, and it is also obviously my company have to pay for that.
correct.
So being in the client side, this is the very important thing:
Yeah,
coordination between the site, the architect, the plumbing consultant, and obviously our structural team.
yeah, true. So which thing do you find, because you have also worked as a structural designer yourself,
Yes.
so working as a proof checker is more difficult or working on fresh designs is more difficult?
No, I think proof checking is more difficult, and especially being in the client side,
Yeah.
because when I'm designing, I'm free to give my opinion.
Yeah,
I can make the drawing in my way. But when I'm proof checking, then I'm checking someone else's work. So in
yeah,
that case, yeah, codes will say something. We have to follow the code. But in that case, I have to think what the designer have thought while designing the structure. So
yeah,
yeah, I think proof checking is more tough than, because when I'm commenting on his work, obviously I should be very you can say careful, or I should be very confirm about my comment.
correct.
So that is very tough. Seems.
Yeah. So I must tell the audience over here that Sandeep ji is one of the, I would say, one of the most passionate structural engineers I have ever seen till now. So his passion for structural engineering as a whole is just remarkable. I
Thank you so much. Thank you so much,
या
sir.
इतना इतना एनर्जी आप कहाँ से लाते हो? दिस इज व्हाट आई फील समटाइम्स.
No, the
So
thing is, I always tell you that the things I have learned from you, and I'm learning from other people. Like when you learn from a proper place, or you can say when you learn in depth, then the learning में मजा ही कुछ अलग है तब.
yeah, that's
Yes.
very kind of you. I must ask also that you also take online courses for structural engineers, and you are a content creator. So how has that thing uh, made you a better structural engineer? I mean, teaching others, has it made you a better structural engineer? What do you feel?
Yeah, obviously, because yeah, when I have started my YouTube channel and my learning platform came after maybe 4 5 3 4 years. Like I have started my YouTube channel in 2017 when I was in college. So it
Acha.
was like for fun. I have never thought that it will be for something like that it is now. So yeah, gradually I've started solving the problems of others first of all, what I did, I just copied some videos from others and I made the content, the same content. But when people have started asking questions, I have started working on those questions or on those doubts. So during this process, I was also getting doubts. So
Yeah,
yeah, while solving others' doubts, I got the doubts, and I started solving my doubts also. So
correct.
yeah, like teaching others will teach us in the best way, I think.
Yeah, yeah, true. I also feel that because when we also conduct some online courses, we are also learning in the process. I mean, the participants feel that they are learning, but the truth is that we are learning ourselves with them.
Exactly, we are learning more than them actually.
Yeah. So I must tell the audience over here that he has a platform by the name of Illustrica, and it is a popular platform. He has his Android app also, and it is a very good content creator on the YouTube. So his channel, you will see some very informative videos. I've also learned a lot from watching those videos actually. So very informative and very good videos he makes, and he writes well on the LinkedIn also. He has, I think, 5,000 followers on YouTube page. You must try to visit his page by the name of Illustrica. Right.
Thank you, sir. Thank you.
So yeah. So anything that you would say in the end before we move to the next segment?
I will ask to everyone. I don't know. Maybe most of the people are senior to me. If there are my juniors and who have started their career, I will just say one thing: just keep learning. And if you stop learning, then you are done. Actually, in today's scenario, when the competition is so high, we have to continue our learning every day. Maybe uh, we can invest a small time every day. It is not possible for everyone to invest time or maybe give time, but we have to continue our learning. Otherwise, it is very hard to sustain in this scenario.
Yeah.
Thank you.
Thank you,
That's it.
Sandeep. Thank you so much for
Thank you, sir.
taking out time on a Friday evening. He just came out from the office at I think 8:40, and then uh, from a
It's
long
it's my
office, from a
it's my
12-hour
pleasure
long
actually.
office. No, that's so kind of you. So he came back rushing from the office to take part in today's episode. Thank you once again, and it
Thank
is
you, sir.
always good to interact with you. Thank you. So that was engineer Sandeep, and we were interacting with him. Uh, in the next segment, what we will do is that we will take some of the ideas that you people had shared. So we had called for ideas, asking for how to overall improve our work, how to improve the efficiency, and how to uh, make our work more productive. So we had asked for some comments, and now I can take some comments from the audience also about what they think about this issue. How should we, as structural engineers, improve our efficiency and improve our productivity? So, engineer Rahul Brijpuria says by using software and Excel, Microsoft Excel efficiently, we can improve the work quality and save time. Yeah, so I totally agree with this that Microsoft Excel, I think, is one of the most underrated softwares uh, that we structural engineers think of. Underrated means that we do not uh, quite understand the importance of Microsoft Excel. I would say that Microsoft Excel is very, very important, and it can help you save a lot of time. It can actually what to say, bring a lot of efficiency in your work. So what I would tell you that you should learn Microsoft Excel, and you should try to make small spreadsheets in Excel. Just trying to make simple spreadsheets, start with a basic plus minus multiplication division, and then go on to some advanced calculations. At the end of the day, most of our calculations are, I mean, most of the problems are simple plus minus division addition, isn't it? So you can learn it quite easily from the YouTube videos, from online content, and try to apply these Excel sheets in your day-to-day work. This is one thing which I think will greatly improve your efficiency and productivity. Then Engineer Venkatesh says, I think he's in the audience today. Engineer Venkatesh says, learning automation of mundane work using the computer programming will improve the work efficiency of engineers. Yeah, true. But that depends on what do you call a mundane work as. Mundane means clerical work or work which involves repetition, work where you don't have to apply a lot of mind. That is generally called as mundane work. So, I mean, if I ask this question to the audience, what is one mundane work or one clerical work that they do in their day-to-day structural engineering that they would like to automate? Yes, anyone would like to comment? What is one work which they think is quite clerical in nature, where they don't have to apply a lot of mind, and that is one work which they would want to automate uh, to save their time? Yes, anyone? For me, I think it would be finding out the reinforcements for your beams, or finding out the reinforcements for your slab. Once you have done the final sizing, and once you have finalized the sizes, once you have ensured that everything is all right, I think the final reinforcement calculation is quite mundane. This is as per my, I mean, my, uh, what to say, my idea, my thought. Rahul is saying detailing is mundane. Mr. Thomas is saying beam design is mundane. Yeah, finally finding out the reinforcement, it is quite a mundane work. A lot of repetitions. You have to go on doing the same thing over and over again. And especially if you are doing it for the ductile design, then there are a lot of load combinations. Some load combinations involve seismic, some are non-seismic. So you have to keep on checking one beam for different combinations. So it's quite a repetitive work that we face. Yeah, detailing, Rahul is saying. No, but detailing is quite an important part. I mean, for detailing, you have to apply a lot of mind. It is not a clerical work, in my understanding. Then Saksham is saying modeling instead, he finds it mundane or clerical. But then you cannot possibly automate it, because every model will have something or the other which is slightly different, which you cannot expect a software or a computer to do it on its own. So I think even though it might be mundane, uh, you cannot delegate this task to a machine. Mr. Kashyap is saying AST calculation. Yeah, I agree. Final AST calculation, once you have done everything, that is quite a repetitive and a boring sort of work. Yeah, I do agree. Mr. Sachin is saying in bridge design, applying the loads of vehicles, he finds it not very interesting. Yeah, personally, I don't do bridge designs, so I would not be able to uh, relate this thing with you. But yeah, for some bridges which we had done, mostly they were pedestrian bridges, and one or two road bridges. So yeah, load calculations and the multiple load combinations that you have to make in IRC 6, as per IRC 6, those are quite boring work actually, where you have to make 300, 400 combinations. That is quite a boring work. Yes, but you cannot possibly automate it. Here we are talking about things which you can automate it by using some computer programming. Weber is saying drafting work, again a thing that you cannot possibly automate to a machine, because every drawing will have something which requires mind to be applied, and which is not typical or not repetitive. So even though it is boring and clerical, you might not be able to relegate it to a machine. So these are few ideas and comments that we had received from the Google form, which we thought we will just put out over here. Then we had a comment, though it was not an idea. He had said that Engineer Anshuman Adhikari, he says, what I observed on field is that people are not very confident about the logic behind a few modeling gimmicks. Yeah, I agree. So there are a lot of gimmicks, lot of tricks which people apply in their model, in their design model, or in their calculations about which they are not quite sure. Yeah, I agree with that. So it was more of a comment than an idea actually. So yeah, these were some of the ideas. So think about this. One takeaway you can have from today's discussion is try to make some Excel sheet which will save your time and effort, and you can try to make it for some repetitive work that you are doing, mostly some calculation part. It can be as easy as making us just a plus addition sheet where you just add two numbers and it gives you a result. But uh, it would be good if you can make some spreadsheets and try to save your time, right? And actually it also I mean, as I told in the beginning, that we do not quite realize the true potential of Excel. So when we learn more and more, only then we will realize how powerful Microsoft Excel can be. Okay, good. So this is what we had to say over here. And we had said that we will be taking 1 hour. We are just on the verge of 1 hour. And in the end, if we have some time for open discussion or any thoughts which you would like to share over here, so we invite your comments, anything, short comments in open discussion that we would like to have, and then we can close today's episode. Yes, anyone? Time for some open discussion. So I think Weber was saying a few things, and he was saying, so he says, Weber is saying there is a common practice followed to make zero density material in STAD. So this is a part of open discussion. We are taking his comment. So he says there is a common practice followed to make zero density material in STAD to transfer wall loads to adjoining beams. However, there are two major problems as the slab load, and he continues, is incorrectly distributed. Secondly, the wall load is transferred to beams in the direction of wall load, but in actual condition, it's a long comment actually. In actual condition, the load shall be distributed the beams along the short span in both cases where walls are along or perpendicular to the span. It was such a long comment that I forgot what he was saying. I think he's saying that it is a common practice to make zero density material instead to transfer wall loads to adjoining beams. Zero density material. I mean, I'm not aware of this, because if you make a zero density material, it will not take part in the analysis. It will not run the stiffness based analysis for it. So I'm not quite sure if a zero density material works in the analysis. Yeah, I'm not sure. Okay, so in the end, we are open for some discussions if you want to have some discussions. Uh, Kashyap is saying front long cantilever of your project. Of your project? Front long cantilever of your project. I'm not sure what he's asking. Okay, so this was our first episode today. Yeah, Illustrica is saying he's about talking about dummy beams. Yes, so Weber is talking about dummy beams, but the question is not quite clear to me. So I'm not sure. All right, so this was today's first episode. We conducted this episode in the hope to bring structural engineers on a common platform. So I hope today's first episode was good, and with time we'll try to evolve it in a more, I mean, with time it will evolve. Everything evolves with time. We learn new things with time, and accordingly we change what we are doing. So with time, we will make it more inclusive, more interactive, and we will make it more engaging. Okay, so that is all what we have for this episode today. Mr. Rahul has an interesting comment, so I must take his comment. He's saying Excel is like a dodhari talwar, which has edges, sharp edges on both sides. So Excel is like a dodhari talwar. Some people are using the Excel sheets developed by someone else. Yeah, that is absolutely, I agree. That, see, Excel is just like a calculator. So if you are not sure what is happening inside that calculator, and if you are using someone else's calculator, it is risky business. All right. And sometimes even I do not remember. Let's say if you ask me 6 months after about a sheet that I had prepared 6 months ago, sometimes I also don't remember what I did in that sheet. So it's very important that if you are using some Excel sheets, try to develop them on your own, or at least try to know the background calculations behind it. Only then start using someone else's Excel sheets. Otherwise, it is quite risky. All right. So don't do it unless you have the in depth understanding of what that Excel sheet is doing. Very important. Just like the case of software. So software is also like a dodhari talwar. If you are not sure what software is doing, you will end up creating blunders. So you should be sure what the software is doing, why it is doing a particular thing. All those aspects are important to be understood. Good. So I think we had a good time in this episode, and we will organize such episodes fortnightly. So where we will have discussions with our fellow structural engineers. So thank you for joining on a weekend. So all of you took out time and joined us on a weekend. I mean Friday evening. So thank you for that, and have a good weekend, and we will see you next time. Till then, bye bye and good night. You can connect us on our Facebook page, on our YouTube channel, and on our LinkedIn channel. And do visit us on AuxEn's.in. So, once again, thank you, bye bye, and uh, good night.